Hello, everyone. Welcome to the first episode in the series of many, where we will be interviewing PhD students from the Department of Chemistry. Join us as we learn what exciting research they conduct and their experiences in IIT while doing so. Our first guest for today is Farheen. Okay, Farheen, could you introduce yourself, please?
Hi. So it's evening right now while we're shooting this. So good evening, first of all. I am Farheen from the Department of Chemistry, but of course, I was working under the supervision of Professor G.K. Lahiri. We are basically basically I would call myself as an inorganic synthetic chemist. So that is how, and I think I just took 5 years plus the COVID time to complete my degree, and that's how I just defended a month back. So it feels good and it's really nice. And thank you to you people for inviting me for this talk.
Yeah, thank you, Farheen, so much for being with us. And I think since you have defended your thesis, we can call you Dr. Farheen. Is that okay?
That would be very obliging, but it's up to you.
Right. So as a research scholar, I guess first question would be like, how would you describe your research, like the work you have done for the past 5 years?
So, as I already have mentioned that I was an inorganic synthetic chemist. So the work in our laboratory, like under the supervision of Professor G.K. Lahiri, it is basically more fundamental and it's at the interface of inorganic and physical chemistry. So, and I believe that I really, really like the science that I do. It is very absolutely fundamental. It deals with something as simple as tracing of electrons, and I think that is the first chapter that we get from where we get our interest into chemistry. And if I technically describe it, I would say that I have worked on probing redox active compounds, which are basically compounds that can take up or give electrons, called as oxidation or reduction. And then we characterize them in the various oxidation states or the redox states that they exhibit. Now, this thing is quite challenging because we generally deal with a set of dinuclear compounds, and then you have a redox active bridge, which is also participating in the electron transfer process. So like formulating an exact oxidation state at a very intermediate redox state, which you cannot hold, which is not very stable, it really is very challenging to get out the right formulation for these complexes and describe what is to like actually happening in these set of complexes. And then we basically try to I have basically tried to conclude some very fundamental inferences from all the studies that we have made. And for all these studies in our lab, we did both the experimental techniques using a lot of an array of basically instruments and experiments. And then we also verified our results and synchronized them with the theoretical calculations. And then for a certain set of compounds, I have also explored them for checking any transformation reactions that could be stemmed out from them. So that was something that formulated my thesis work for the PhD.
Okay.
If somebody didn't know about, say, redox potential or things like that, how would you explain your work to a person like that? Yeah.
So I think electron, I would wish that the person really knows that what an electron is. It's something, it would be too difficult to describe that for me
No,
right now.
let's.
So yeah,
Right.
we'll take that
We
up.
start with
And then,
electrons.
yeah,
Yes.
yeah. Okay, so so when you have an electron in a compound, and then so you have to give it some energy, you knock it up with some energy, so much so that it leaves the shell where it is. So that process, we'll call it as an oxidation. And then, or maybe you supply an external stream of electron into the compound or an electron into the compound, so that the compound now accepts that electron, which is not easy because there are uh, there are repulsions in the compound and everything. So you need a certain amount of energy, and for that we apply a certain amount of potential, and that is what we check through through a process called as technique called as cyclic voltammetry. So we basically apply a potential, and then at that we check out, we get a signal as to where at what potential the electron is getting knocked out from the shell of the compound that we are using, or we check the potential where the potential has put in an electron into the system, an electron or two or maybe many. So that is how we get the different redox states of the compound. And then after getting into, like for example, I have knocked out an electron from the system. Now I have to realize that, for example, there are two metals and one ligand, and each one is capable of like of oxidation to happen, to participate in oxidation. So then we really have to figure out that from where, like from which metal, or from where, like the metal or the ligand, from where has the electron actually gone out. So for that we need to have a lot of techniques. They come in and they get involved. I go back to the technicality. We would say a technique like EPR spectroscopy, or like spectroelectrochemistry and theoretical calculations. These things, they help us. So that is something that I termed as tracing of electrons while applying the cyclic voltammetry. So that was the basic thing. Yeah.
Okay. So, uh, how do you think these fundamental research that that you have understood will help, or do you think there is what is that called, potential use of these things that you have found?
Yeah, so since the research topic is very fundamental, the results will have to be fundamental.
Mm-hmm.
And I think being a PhD student over here, I think we all can recognize the importance of fundamental in any
Yeah,
field of study
yeah,
that we do. So yes, so the fundamental things, like when we can recognize that in a particular set of molecular framework, if you have a functional group which is, in general, we know that it is susceptible to an oxidation process, or it is susceptible to a reduction process, and now you have a designed molecule where it is behaving differently. And then we have this all of these studies and techniques all lined up, and then we conclude that for this exceptional molecule that we have designed, the generalization is not existing. So that is a fundamental conclusive result. So that would add to the literature in a significant way. And besides the fundamental thing, if I speak of in a very broader sense, we also, like for example, when I told you that there are two metals and one ligand, so it can happen for on two electron oxidation or something, that there can be one metal in, there can be two different oxidation states that a metal can bear. For example, one has oxidized and one has not oxidized. So they both are now in different oxidation states. So in that case, these complexes are called as mixed variant complexes. Now these complexes, they are of potential use. They can be used and for electronic communication, because communication is basically the flow of electron. You can channelize the electron. The more it is delocalized, the better it can be used as an electronic wire. You can also use them in molecular switches, in nano junctions, and in many things. So it's up to your creativity and the literature that is surfacing, that you decide that where can you relate or your research to. And besides that, you can also use these complexes into biomimicry, because most of the enzymes that are there, they're working on the electronic thing that you shuttle out one electron. They basically work on electron shuttles. So these compounds, they serve as really nice models where you can study that how a compound is behaving if you take out an electron or if you put up an electron. So if you have a compound which really mimics an enzyme, so it really helps you to have biomimetic studies on these complexes. So, and then I would also say that these complexes, like the mixed valent complexes, they're also very much in use as dye sensitized solar cells, which is a trending thing at the moment. So yeah, there are a lot of applications. We have not worked on it directly, but we can implicate the results definitely.
Thank you so much for explaining your thesis work to us. So 5 years in lab and IITB campus, so you must have a lot of memories. So if you were to share something that's really memorable to you, an experience, what would that
I think there, if you speak of memories, each moment is a memory, and in that sense, it's just too many to be said. But yes, if I'm asked to recall, I would say that my lab mates and my friends, including me, we were foodies. So we really had a good time in the lab where we would have a party going on every alternate week, and anyone who sponsors a treat, we welcome them. So that was the spirit of our lab, and that kept us working and fueled. So that was really, really nice. And also this, that my lab mates and we all had this thing that we were firm believers of wanderlust. So like we would always find an excuse good enough so that we could have a lab trip at least once in a year. And I would say that even our professor was very our supervisor was very supportive in this sense, and he would really encourage us to go over there. And then if I come on a very casual sense, I would say that since I'll be leaving the institute very soon, I would be missing all the good sarcasm that was there in between the lab mates and the friends, just to pull each other's leg. And I think each would account to a memory for me.
If there's any place that you would suggest someone to go to, being such a foodie, what would you ask them to go to?
It depends what you want to do, but then I believe Sufyani biryani from Mirchi and Mine.
Okay, good to note that
choice?
for the future.
Yeah.
Right. So lastly, to the students, to the scholars who are currently pursuing PhD or are wishing to do PhD, so if you have some like advice or let's say words of wisdom to share, what would that be?
Yeah, I'm just a very new doctor, so I don't have much to share. But yes, I would say that for the PhD students who are still coming up to this, it's first of all very important for them to know that what do they want to achieve. Sometimes I mean, speaking from my experience, like having reflections from my experience, I know that most of us, we come and we just join a group, and then it's only much later that we know that okay, this is what I am doing and this is what I'm supposed to do for the next few years. Although I think it would be a nicer way to start with, when we know that what is it that is our subject of interest, and then we approach a group and try to get imbibed in it. I think that would be a good start, and for all of us. And then I would say for the people who are into PhD, that PhD is actually a very nerve-wracking degree. And besides that, you'll have struggles in your own academic sense. I mean, besides those academic struggles, you'll also have struggles from anything around in your environment. It could be anything which could be stressful for you. And the key is just to be patient and to hold on. I would say the holding on is the key for doing a PhD. And if you're determined enough, I think you will ace it. Just believe in yourself, don't be discouraged. You'll ace it in your own way. Do not compare yourself with anyone else. Do your own good work.
thank you for joining us, and we'll join you with
Yes.
a new person another time.
Yes.
Sure.
Thank you so much, Farheen.
Okay,
Yeah.
thank you so much. It was lovely
Yeah.
having being
Yeah.
with you
Thank you
all.
so much. And
Okay,
Thank
thank
you
you.
so
Bye
much.
bye.
maybe